So we want to look at uh, what I call regular language. Let us see. Regular language there simply means it's like we are checking out for what a DFE accepts. So regular language, yes, regular languages. Now, next one we meet, we look at how to convert from DFE to NFE. So we'll check out the conversions. So, but all right, let's write. Let's write. A language, a language is said to be regular. Let's write. A language is said to be regular. A language is said to be to be regular, to be a regular language is set said. Pardon? Is said to be a regular language if and only if some finite state machine recognizes 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 it. Now, so a language is said to be regular if and if only some finite state machine recognizes what? It. Now, look at what is here. Not recognize, not regular language. What is not regular language? Which are not recognized by any. So any language that is not recognized by, let me just change. I think any language that does not recognize, that is not recognized by any FSM. Next one is any language that requires memory. Any language that requires memory. Now, you know, I was telling you, I told us something when we started, that I said FSM is a type that has a very little memory. So any language that requires memory, it is not it is not recognized. It's a regular word. It said the language is said to be a regular language if and if only some finite set machine recognizes it. So anyone that require memory, it means that FSM, it does not recognize it. So why is it so? One is that memory of FSM is very limited. The memory is limited. Two is that it cannot store or count strings. It cannot store or count strings. So look at this example. We have AB, ABA, BB. ABA, BB. If you ask this guy here now, the FSM, to repeat this thing that has been written, you type ABA, BB. This guy has no way of repeating it. Now, the only reason why you can repeat something is because that thing has been stored. You have a record of that thing. You have where that thing has been stored. That's why you can give that thing back. Now, because of this guy, it said it cannot store, neither what count its strings. Therefore, if you ask it to repeat the same thing, it won't be able to do that. So, because of that, we say that this is the reason why it is not a what? It's not recognized. So another one here is, okay, let me give you this note. It's very important. Very important note. The string ABABB was repeated because it was stored. It was repeated because it was stored. Are you there? It was repeated because it was stored, comma. But FSM does not store or count strings. So the reason it was repeated, it's simply because it was what? It was stored or counted. But FSM, which is finite state machine, does not store or count strings. Therefore, the string is not FSM. This string here is not FSM. Okay? So therefore, this string here is not FSM. Are we together? So cannot store or count is written here. Cannot store or count strings. It was stored. It's because it was stored. But FSM does not store or count strings. Does not store or count strings. You get it now? Therefore, because FSM does not store or count strings, it means that that string is not what? FSM, which is this string here. This one here is not FSM. If it's not FSM, it simply means what? It cannot be stored.
I mean, with no FSM, it can be stored.
If it is not FSM, let's take it again. Therefore, the string is not FSM. That means that it is only FSM. That's when it can be stored. Yes. This one as it is now, this is not FSM. Reason because it repeats. This we have this here. ABABB. There's a repetition of it. It can be stored, yes.
And it is not FSM.
It is not FSM.
I mean, anything that is FSM
Cannot be repeated. Yes, because it cannot store or count the strings. So this can't be recognized or designed by FSM. So if we want to design or recognize this thing now, we can't use FSM to do that. So another example here is, look at this, A and B and A and Bn. We know that this A and Bn simply means, just like when you say 2 to the power of n, it means a number. You get the n there is a power. So I could say that n, let it be what? 3. I could say let it be 2. Okay. So let's just assume it is 3. Okay. So, and this one, so assume is a 3. So we have this now. Now, if you look at this, this is different from this. Why is your face like that? Oh. So if you look at this, this is different from this. So FSM can keep this. Reason because they are not the same thing. So if he finishes these strings, come to this place, it's like he's starting another string entirely. There is no repetition. So let me give you this note. FSM can't keep counts. It can't keep count the number of A's FSM can't keep count the number of A's in order to give the same number to B. The numbers of
Keep
A's
count
can't
of.
keep count of A's. FSM can't keep count the numbers of A's in order to give the same number to B. See, how many numbers do we have here? We have 1, 2, 3. It can't keep count. So, the above example string cannot be recognized or designed. Cannot be recognized. I think I've come to understand something here. The above example strings cannot be recognized or designed by FSM, which is what? Finite state machine. See, we have A, 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 A. The only reason why this guy here can repeat this is because he has stored it that, oh, the first one we did was what? A to the power of what? 3. That's the reason he can't come here and say, okay, oh, I don't understand now. That n is to the power of 3. Therefore, this b2 will be to the power of 3. So it's going to be b, b, b. That's b, that's b cubed. But since it is repeating a, it comes again. He was able to recognize that, oh, this A is 3. Therefore, B will be 3. It simply means that there is a storage there and there is a counting of strings. And it cannot be what? FSM.
So it must be totally different.
It must be totally different. That's what we are checking out for. This one helps us to know what FSM recognize. Examples of this machine we are talking about, which is FSM. So something that like real life hardware devices that really uses this FSM rather. So examples of FSM. So the first example we have here is we have that of traffic light. Now I want to believe that if you're watching this video, you must have seen a traffic light before. And if you've not done, so probably you pause this video and go and check out for a traffic light. So now the reason why you have to check first is you need to study how traffic light works. Maybe just just stay close to it and see how it works. For observe so many things about it, because that will really help you have more understanding to what in this FSM journey. So this traffic, how does traffic light work? We know that traffic light, remember we said that FSM does not count, neither does it store strings. Another one is that FSM does not have a memory. Therefore, if a thing doesn't have a memory, it means there is a model it follows. And the model simply means algorithm. It follows a particular algorithm, which is step by step. Okay, now that step by step is what we call a state. From one state to another, from one state to another. And before, once we are in a particular state, what determines the next state is whatever is the whatever input we have. And that input, sometimes the input actually follows what the algorithm is saying, which is the algorithm there means the rules that is guiding that model. So now we have on the for traffic lights, we have what we call the red. We also have what we call the yellow, and lastly the what? The green. Now look at this from this perspective. Okay, in that this is the red here. So we are using this a DFA now to see how this thing works from state to state. If we have red here, what determines red changing from this state, moving from this state to yellow state, is the fact that traffic light has what we call a timer down to 0. That timer simply means you will always see a traffic light, something like a count. It counts from I think from, is it from 10 or so. Now it differs. Sometimes it is maybe based on the environment or the state or the country where it's being installed, or sometimes based on the people who installed it. So they decide the way they program it, like, okay, at every 10 seconds, at every 20 seconds, move from a particular state to another state, particular state to the next state. So you could see that in that case now, that's, you could see that is what determines what, when, and what the next state will be like. Now, another one is another way of moving to the next state or talk about traffic light is like a button. Somebody staying probably where the button is and the person doesn't use timer. The person just decide to, like, okay, let me just press this button and it moves to the next state, and like that. So either of the two can work. Now, from here now, we are using the timer now every 10 seconds. From this 10 seconds from red, it moves to next one, which is yellow. This is a state on its own. The third state there now, that's green. 10 seconds again, it moves to what? From this yellow to green. So this thing keeps doing this, and it's following a particular model. That's for that. Now, another one here, practical example, is what we have called the ATM, which is automated what? Teller machine. Full name, automated teller machine. Now, how does this thing work? We know that if you have not, now let me explain this. If you've not used ATM before, I would like you to pause this video and go and make use of ATM, because go and, if you don't have an account, go and open an account first. If you don't have if you don't have ATM card, you need to go, because it's when you have all these things you can explore this thing I'm saying and have a better understanding. Okay, that it follows. So another is that that POS. It's because POS is just more like a mobile ATM machine. You get it now? So that POS. Now, how does this work? You know that the first state of ATM, for those of us who have been using ATM, I'm referring, let's talk now. The first state of ATM is the machine has a finite number of states, such as the card insertion. Now, the card insertion, the first state, but before card insertion, there is a state of, they call it I do state. I do state. Yes, that state of that I do state is the state whereby once you approach the ATM machine, that's where it's not executing anything. You just come there, and on the screen of the ATM machine, you are seeing some kind of adverts like that, blah blah. That state, it is idle. The machine is not working. It's idle. No execution of any
I think in
any
that state,
data.
the modem is not functioning.
Nabi.
Because that for that advert to be doing continuously, it's
Yes,
like there's the memory functioning there
exactly. That keeps that
in that
advert.
advert.
So once there is an insertion of card, it moves from that state, ID state, to the insertion of card. So you could see now, once you insert your card, after from the ID state, you insert your card. Then ID state, the next thing that happened there is that it requests for your what? For your pin, the your card pin. Now, the only reason why it will move from, this is ID state. Next one is card insertion. Card insertion. The next one, now once you move from here, the next one you want to move to is, now it can only move from this card insertion to another state, provided you put in the correct what? Correct pin. If you fail to put in correct pin, you can't move from this state to another state. You can see the algorithm, how the algorithm that is following the model, how this model is designed. You can't move from this state. Once you put in your card correctly, then it takes you to another state. And in that state there you have let me read out something for you. Say ATM machine changes state based on the user input. See, based on the user input. And for example, when the user insert the card, the machine enters the card insertion state. If the user enters the correct pin, the machine enters the pin entry state, and so on. Now, after that, let's say pin entry state, you've entered there, pin entry state. Now, from here now, it will now give you options of do you want to check account balance, or you want to withdraw, or you want to transfer, you want to buy recharge card, or you want to pay some kind of utility bills and the rest. So you pick that. Now whatever you pick will determine whether it will move to the next state or not. If you refuse to pick any one from those options given to you, it can't move to the next state. So moving to the next state, let's say we are using withdraw for example. You move to the next state. Now it has entered the state of withdraw. The next thing that happens is that you are given options of what? Choose picking what? The amount, entering the amount you want to withdraw. Or probably is it service? Is it current? Is it which one again? I think current and savings are mostly used. So after that one now, you now move to another one where you begin to pick the amount you want to withdraw. Then after that, I think it moves to where you that receipt is sometimes is optional. In some cases they don't ask you that. So you could see that how now what we are trying to pick out here is just to show us what the machines, physical machine, hardware machines that uses this thing called FCM. So you should see that these things are not something that are spirit. They are not existing in the spiritual world. It is something that we relate to it. We do them, like we practice, we engage in those things. And the reason why so many machines we relate to them is if because they are obeying this FCM, FSM machine. So I guess this is very clear to us now. And so the next one I want to move to now, let us see how we are going to do a few things, which is NFE. So I'm going to spot this video from here and continue the next video. Make sure you watch the next video. Make sure you watch the next video so that you follow up as the lecture is going on. Thank you very much, and don't forget to like and don't forget to subscribe. Encourage me. Bye.